A very good evening to you. I hope well. Please just let me know if you can see the slides and you can hear me okay?
Yeah, we can see your slides.
Excellent.
Yeah.
All right, so we'll get started. This is actually the last session that we're going to be having. So I hope that you are doing okay so far in this unit, and it will be the last unit. So I'm wishing you all the best. We'll obviously talk again via email if you do need any assistance after this, but hopefully this session will also help you. It's been a nice pleasure interacting with you these past 7 weeks. It's funny how time flies, but we're here now. So we will get started, and the session is being recorded already. We are looking at sections 4.2, 3, and 4, Unit 7, and we will start with the first question from section 4.2. So I'm going to try and, since it's the last session, not keep you too long. And also, since we've been doing this a while, I'm going to just try and go through the session to get through all the questions. And if you do have any question at all, as we go through the questions, please just let me know and I will clarify things. So I usually explain a lot and write out a lot of things, but I'm just going to go through the worked out solutions for this last session. All right, so the first problem says express the log form exponentially. So we know that we have the log form, and there is a representation that is exponential. So that is what we want to do. If we see the problem that we're given, it says 2 is log of 144 base 12. Right, so we want to write the exponential version of this. And for us to be able to do that, it will be 12 to the power of 2 is equal to 144. Right? So let's just have a look. So 12 to the power of 2 is equal to 144. So that's correct. And this comes from, if you want to see where they explain it in the textbook, comes from page 189 of your textbook. And basically it says that if we have y is equal to log x base b, this just means it can also be written in exponential form as b to the power of y is equal to x. Right, so when I started doing these tutorials, it was a while ago, and I think Drake was still very popular at that time, and he had a song that goes, "You started from the bottom and now you're here." So I always used to make that joke. So you start from the bottom, so from the base, take the power of the other side, and then you end up there. So b to the power of y is equal to x. Right, so I don't know if that helps anyone at all at this point, but it's what I used to use as an example, and it used to be very popular. But we shall continue. So let's have a look at problem number 4, which is now asking us to do the reverse of what we did in the previous problem. So we now need to go from exponential to log. Okay, so we have an exponential function. So 32 to the power of 3 over 5 is equal to 3. And we want to be able to write that in log format. So for you to always remember when you're dealing with exponential things, this is what we call a base. So you would know in your log form, your base would be base 32. So that would be log of 3 base 32 equal to 3 over 5. Okay. So now let's have a look and see. These first few questions are just for us to familiarize with exponentials and logs, because we'll start using them in solving equations and doing other things. Okay, so this is the same thing that we saw before, the rule that comes from page 189. And then if we go to problem number 44, we now are asked to find x. So to solve for x, we're given an equation, and this equation has a log in it. So we will use the rules that we know for logs, and try and solve for x, right? So here, if we see log of 36 base 6, we're not asking you to use a calculator at this point. So this must actually say without the use of a calculator, right? Because one can just argue and say, I know I can just go and substitute this into the calculator. I will get an answer, and then I can solve that equation. So we're going to do this without a calculator. So how we're going to do that is we're going to make this into write it in its exponential form. So for us to do that, we start from the bottom, take the power of the other side, and end up there. So we'll know 6 to the power of x minus 1 is 36. So that's what we have here. Okay, right here. And then we have a base of 6 and 36 that on the right-hand side. So we write these two numbers using the same base. So a good base would be 6, because 36 is just 6 to the power of 2. And then now you'll have 6 to the power of something equal to 6 to the power of another thing. So these two things must be equal, right? Because it's the same base. So therefore, x minus 1 must be equal to 2. And then you solve for x and get x is equal to 3. Right, so we've solved that, and always check your solution. So we're not going to do that now, but you're going to go and substitute 3 in there and say, okay, 3 minus 1 is 2. And then now you can check with your calculator, log of 36 base 6 must give you 2. So then you know your answer is correct. All right. So let us continue to section 4.3, problem number 4. We are given, okay, so we're told to let log of 2 be A, log of 3 be B, and log of 5 be C. And then we need to express the indicated log in terms of A, B, and C. So they just want us to rewrite log of 5 over 2 using these representations. So log of 2 will be A, log of 3 will be B, and log of 5 is equal to C. So we're going to end up with an answer that has only A, B, or C. Okay, so here it just forces us to practice the rules of logarithm. So we know that log of a quotient, log of a fraction is log of the numerator, so that's log of 5, minus log of the denominator, so that's log of 2. And then now we know log of 5 is C, and log of 2 is A. So our equation is just C minus A. All right, so that one was quite a quick one. So if we look at the next one, it is also asking us to use the same log of 2 is equal to A, log of 3 equal to B, and log of 5 equal to C, and now express the indicated log in terms of A, B, and C. So we go and we check, okay, we have a fraction again, so we're going to have log of the numerator, log of the denominator, but then that's not going to help us at that stage, because there is no log of 6 in what we're given, and there's no log of 25. So you must first of all maybe write this in terms of logs that you are given. All right, so 6, what two numbers can you use between 2, 3, and 5 to get 6? Yes, 2 and 3, and then you multiply them, right? So this can be written as log. Our numerator becomes 2 times 3, right? Let's do the same with our denominator. What numbers can you use to get 25? 5. Okay, so what do we do to 5? We multiply it with itself. So you can write 5 times 5, or you can write 5 squared, right? Both are correct. I like to use squared because we're dealing with logs, and we know how we can simplify a power in when we have logs, right? So I'm just forcing us to practice that extra log rule. So the one that I'm talking about is if you have log of I'll use 5 squared. This 2 can then become the coefficient, so that becomes 2 log 5. All right, so we're going to go ahead. You'll have log of the numerator, the log of 2 times 3, minus log of the denominator, which is 5 squared. Then the next line will just simplify. This becomes 2 log 5, and then that becomes log of 2 plus log of 3 because there's a multiplication here. So if we go and do that, I'll just show the solution because we've pretty much worked all of it out. So we are at this point, the 2 comes there and it becomes 2 times log 5, and then this is log 2 plus log 3. We know this is A, that's B, and that's C. So that would be A plus B minus 2C. Right. So we've done exactly what the question asked us to do. And then now, if we go ahead to problem number 32, it is asking us to write this nice looking expression in terms of ln x plus 1, and ln x plus 2. So that ln is your natural logarithm. It's just a log, but base e. All right, so ln x is just log of x, but base e. Right, so that's your natural logarithm. And we are asked to write the expression in terms of only those 3 logarithms, right? So here we see we've got ln of the 4th root of x squared times x plus 2 to the power 3, and then x divided by x plus 1 to the power 5. So you want to write this in terms of ln x plus 1, and ln x plus 2 only. So what you will do is you will use the laws of logarithms. But before we even do that, we don't like this radical because there is no rule that a direct rule that we can use for logs and radicals. So we'll change it into an exponential, into an exponential expression by making this radical a fractional exponent. So that would be ln, and that would be x squared times x plus 2 cubed divided by x plus 1 to the power 5, all to the power of 1 over 4, right? Because of this 4th root, all these radicals are just fractional exponents. So if it was cube root, then it would be to the power of 1 over 3. If it was square root, it would be to the power of 1 over 2, and so on, right? So now we can actually, first of all, get rid of this exponent by bringing it to the coefficient of ln. So that's the first thing we will do. So it becomes a quarter ln of that fraction. And the next thing we're going to do is we're going to say, okay, there's a dividing line here. So we're just going to say ln of the numerator minus ln of the denominator. So that's what we've done here. After actually done 2 steps in one go. So ln of the numerator is 2 things multiplying each other. So it will be ln of x squared plus ln of x plus 2 cubed. So this and that we separated. And then we have the minus ln of the denominator, right? Hopefully everyone is happy with that. Then to move on, we still don't have ln of x because this is ln of x squared, and also we still don't have ln of x plus 1 because this is ln of x plus 1 to the power 5. But these are just now powers, and we can easily get rid of those powers by making them the exponents of those logarithms, or not the exponents, the coefficients of those logs. So we go ahead to the next step and do that. So that power goes there, that power goes there, and that power goes there. And now we have something in terms of ln x plus 2, and ln x plus 1. The rest of the solution there is just multiplying this quarter into that bracket. So 2 over 4 is a half, 3 over 4 is 3 quarters, and negative 5 over 4 is negative 5 over 4. Right. Hopefully everyone is happy with that. We followed all the steps and we've done everything properly. Now to move on to problem number 52. Yes, thank you for the confirmation. And if at any point I go too fast or I need to explain something further, do shout. All right, so problem number 52 is asking us to write the expression in terms of natural logarithm. So we've spoken about what a natural log is, and it's one of the very special ones that we use, and you will find it on your calculator as well. It's written ln, and I've explained that it's just, so for the natural log, its symbol is ln. It is just a log that has the base of e, all right? The one that is also very common and is actually called the common log, as it's written log. It's simply written log, but sometimes you write the base here as 10. So if the base is 10, people actually omit that writing the base. So let me just undo that because the base is equal to 10. It's like when we're dealing with the square root, we actually don't write the 2 because it's the most common one that we use. And then the rest of them, we actually do write the index. If it's a cube root, we write a 3. In this case, in terms of logs, the common log has base 10, and we actually don't write this 10 when we are working out things using it. Right. Okay, so we now need to write log of x squared plus 1 base 7, but now in terms of the natural log. So all this is saying is change the base from 7 to e, right? So change the base from 7 to e, and what we use is called the change of base formula. And you will find this, let me just see, on page 198 of your textbook. So you can go and have a look, and they have a couple of examples there. All you need to do is use that formula, and I will tell you how I remembered it from school and how it stuck. But basically, to change log of x squared plus 1 base 7 to base e or any other base that they tell us to, you have to say log of x squared plus 1, all right, divided by log of your base, and then now you choose your new base. So that'll be base e. If you are asked to make it to base 10, right? For example, from 7 to 10, you're going to do the same thing. So you're going to say log of x squared plus 1 over log of 7, and then you choose your new base, which is 10. And in the case of base 10, we actually don't need to write the 10 because it's the common log, and will know the 10 is implied. But here we are using base e. So once you write log of something base e, that becomes a natural logarithm. Okay, so that's a natural log. And then if we simplify there, we'll have ln of x squared plus 1 divided by ln of 7. Ln of 7 is just a number. If you go on your calculator and write ln 7, you will find a numerical answer. So it's just ln of x squared plus 1 divided by some number. Okay, so we've done that. And I did say, I'll tell you how I remembered the change of base formula. So I just drew a line there, and now I know I need to have log of whatever is at the top divided by, so that's x squared plus 1 divided by log of 7, and then I choose my new base. Okay, I choose my new base, and then now I know the change of base formula. That's just how I remembered it. If you look at the formula on page 198, it says if you have log of some m, base b, to change the base and choose a new base, which is e in our previous example, but we're just going to call it a, some other base that you want to. I just do the split there. So what goes on the top is log of m, what goes on the bottom is log of b, and then you choose your new base. Okay, just my thought process. I don't know if it helps anyone to remember. Okay, so let's now move on to problem number 6. Okay, so find x rounded to 3 decimal places. This is an equation that has logs in it, specifically the natural log. So we're going to treat it as any equation with logs anyways. So it says ln of x plus 7.5 plus ln of 2 equal to 2 ln x. So we'll just use the rules of our logarithms to find x. And I wrote there as I was prepping for the session that please always remember your restrictions, but we can get to that in the end when you check your answers. But I just want to write when you have something with an x inside a log. So here there's an x and here there's an x. Your restrictions, so I'm going to write here, and we'll use this to check or to eliminate some of the answers if necessary at the end. We know that anything inside this, any argument of a log must be positive, right? We know you can't have logs of negative things. So the first thing is that x plus 7.5 must be positive or must be greater than 0. Therefore, x must be greater than, if you take that to that side, negative 7.5. Once you take anything that's less than negative 7.5 and try and put it in there, you'll get an error, so that's not allowed. So the other restriction, and I say end because both have to be correct, ln of x, so you know that x must be greater than 0. So if you take these two together, this one trumps that one because you want only positive numbers and this one is taking some negative numbers. So our restriction that we will use is x must be positive, right? So we've considered everything, and then now we're going to go and work out our solution. Let's have a look. Okay, so firstly, we know that, okay, there's a plus there, so this 2 will be multiplied by that bracket, so we do that there, okay, equal to 2 ln x. This 2 can become an exponent, so we do that here, and then you now have ln of something equal to ln of another thing. So definitely these two things must be equal to each other. All right, if I say ln of A equal to ln of B, then A must be equal to B. All right, so if we do that, some people say divide by ln both sides. Please never say that because that is not true. Okay, you can't divide by ln because it's a function, right? Okay, so we just identified that you have log of something equal to log of something, so those two somethings must be equal. That's why we end up saying this 2x plus 15 equal to x squared. And then this is actually just a quadratic equation. If you put everything on one side, you will see you have x squared minus 2x minus 15, and then you know how to solve these. You can use your calculator, you can use the quadratic formula, but you will arrive at the solution x equal to minus 3 or x equal to 5. Right, and then you check your solutions, and even before you check your solution, you're going to see, okay, we have a restriction that x must be positive from our previous discussion. So this one, we will say it's not applicable, right? And then this one is the one that we can check. If you put it in there, if you put 5 in there and 5 in there, does your left-hand side of the equation equal your right-hand side of your equation? So you can go and check that. But then, yeah, so that's how we would proceed with that question. And then if we go to problem number 30, we also have a log equation. So in this case, now we have base 4, but we'll still proceed as we normally would any log equation. So we see that we have log of 2x plus 4 base 4 minus 3 equal to log of 3 base 4. So what we would do is I would suggest bringing all the logs to one side, and this has no log. So put it on the other side. Some other people would want to change this 3 and write it as something that has a log base 4, and then now you have logs all throughout. But I'm going to take the 3 and put it on one side, take this log and put it on one side. Since we have the same base, I can join this and that, and then we proceed like that to solve, right? So let's go and do that. I put the log on the left-hand side, the 3 on the right-hand side. Since there's a minus, we're going to have 2x plus 4 divided, so log of 2x plus 4 divided by 3, base 4 is equal to 3. So if we go ahead and do that, that is that step. And if we do that, now we know if you start from the bottom, take the power of the other side, you end up here, okay? So 4 to the power of 3 is equal to 2x plus 4 over 3, right? And now it's just a number is equal to 2x plus 4 over a number. So you multiply by 3 both sides. 3 times 4 to the power 3. I think I was lazy to calculate what 4 to the power 3 is, but 4 times 4 is 16, times 4 is 64, times 3, you get some answer. All right, so I was lazy again. And then, so we just solve for x, you minus the 4, and then you divide by 2, and then you end up with, yeah, it was 188. Okay, so 188 over 2, then you end up with x is equal to 94. So if you actually check your answer, so we have one answer, and you go and you check it, if left-hand side is equal to your right-hand side, you find that it works. You also see here, we didn't write the restriction at this point because, well, not because of anything, but let's actually do the restriction and see. So we know that 2x plus 4, so we're actually just writing the restriction, must be positive. So we know x must be greater than negative 4 over 2, which is negative 2. And our answer is actually greater than negative 2. So that's fine, but you still need to just check your answer. All right. Okay, now let's go on to problem number 44. This problem is giving us the equation a equal to p times 1.105 to the power t. This is actually just a compound interest formula. You'll do a lot of this in the B module, but in this module, they actually give it to us. But I think from financial maths, you might remember it. And if you didn't do it, it's fine. It's explained in more detail in the B module. But this is the formula for compound interest. So it gives the value A at the end of T years of an investment of P dollars compounded annually at an annual interest rate of 10.5%. How many years will it take for an investment to double? Give your answer to the nearest year. Okay, so if we want to double an investment, so our investment is P, right? We want to double it and it will grow into A, right? The value will become A. So what should A be if we are doubling P? A must be equal to what? 2P. Yes, that is excellent. 2P, right? So yes, that is very correct. So you'll notice that we end up with, okay, so in this case, we end up with 2p is equal to p times 1.105 to the power t. And these p's actually cancel because you divide by p both sides. And then the equation you end up with is 2 is equal to 1.105 to the power t. And that's just, let me write my power properly. That's just an exponential equation, right? And it doesn't even matter what investment you started with. At this interest rate of 10.5%, it will take you the same amount of time to double it. So if you start with 100 Rand, you'll get 200 Rand in this amount of years that we're going to calculate at 10.5 interest rate, and so on. If you started with 200 Rand, you end up with 400 and so on. So that's the equation that we'll end up with, and it only depends on your interest rate and the number of years. So our interest rate is given as 10.5%. That's why we have 105 there. So yeah, that's the interest rate. Okay, so let's go and calculate. We have an exponential function equation, and the easiest way to do this would be to use logs. All right. So I'll show you the way that I wrote it out in the solution, and we'll discuss another way based on the first 2 or 3 problems that we did. So this is what we had. If you apply the natural logarithm both sides, and it doesn't have to be the natural log, but we will end up using the natural log a lot because the exponential function is used a lot. So it's easier to use the natural log. You could have used log base 10 and so on. Okay, so if we use the natural log both sides, ln of the left-hand side, which is 2, is equal to ln of the right-hand side, which is ln of 1.105 to the power t. Then that t, that power, becomes the coefficient of the ln of the natural log. So that's what we have there. And then now, this is just a number, and this is just a number. So to get t, you divide by ln of 1.105 both sides, and then you'll end up with 6.9 something. And they asked us to do it to the nearest year, so we get 7 years. So it takes about 7 years for you to double any investment and 10.5% interest rate. Right. I hope that makes sense. And I'm just going to work it out slightly in a different way, but it's essentially the same way because we're using logs. So from this point, when we got this 2 equal to 1.105 to the power t. Remember the first question that we did? Maybe I can quickly scroll to it. Okay, we've worked out quite a lot. I think it was the first one. Yes, this one. It said, this is what it means if you have an exponential to go to the log, you do that, right? So we have an exponential equation. I think this one, the second question actually was like that. We have an exponential equation, and then we want to go to write it in terms of a log. We want to write it in terms of a log because that power therefore can come down. So I hope you're fine with that. So we're going to go and do that with our question right at the end. Okay, so our base is going to be 1.105. Okay, so now I know if I take log of 2 base 1.105, this must give me t, right? I've gone from the exponential to the log. And if you want to go back, you'll see this is correct. If you start at the bottom, 1.105, take the power of the other side to the power t, it's equal to that. So that is the same expression. So if you actually put this in the calculator, you will get your same answer that we got when we worked it out this way. Okay, so I'm doing it like this because some calculators actually do have, I don't know if you have your calculators with you. I have a Casio calculator with me right now. Just below the on button, there is a button that says log, and it's got 2 little boxes. That one is the one that you can input a different base. So if I write log and then I put my base of 1.105, and then I put my argument of 2 and press equal to, I get 6.9422 and so on equal to t. So therefore t is approximately 7 years, just like we got there. Okay, so that's just another way of doing it. And hopefully, as we got to the last problem, I did not confuse anyone. Okay, so this is actually the end of our session. If you do have questions, please shout, but I'm going to now stop the recording. All right.